Hello friends, in this lecture we will see two-dimensional array. In previous lecture we have seen one-dimensional array initialization, one-dimensional array declaration, and also how to read and how to print the elements of one-dimensional array, and also we have seen some programming examples on one-dimensional array. Now we will see two-dimensional array. This two-dimensional array is nothing but it is a table, or you can call it as a matrix. I think in mathematics you have studied matrix. So matrix or tables, both of them have some rows and some columns. So here these rows, number of rows and number of columns are called as order of a matrix or order of a table. So this two-dimensional array is an ordered table. It is ordered table of some values or elements. So what is the meaning of ordered table? It is not only simply a table of elements, it is ordered table of elements. It means that we have to mention how many number of rows are there in that table or matrix, and how many number of columns are there in that table or matrix. And in those locations, or in those blocks, which values or which elements you are going to insert or store, that will be done by scanf function. Okay, and two-dimensional array is a matrix of some rows and some columns. It is a two subscripted variable. So in yesterday's class, in first lecture of this module, we have seen that is how to determine the dimensionality of an array. The array may be one dimensional or two dimensional or three dimensional or multi-dimensional or n dimensional. So how to find out the dimensionality of that array? So by just looking on the number of index, or how many number of indices, or how many number of subscripts are present in the declaration of array. So if there is only one index in the declaration of array, then it is a single dimensional array or one dimensional array. If there are two indices or two subscripts, then it is called as a two dimensional array. Now we will move to the syntax of declaration of two dimensional array. First we have to write data type, then we have to put one space, and then you have to write array name. Then immediately you should write how many number of rows you want to use and how many number of columns you are going to use. After that, these number of rows and number of columns should be present in square brackets or angle, square brackets. So this declaration should be terminated by again semicolon. This is the syntax to declare the two-dimensional array. First data type, then space, after that array name, and immediately number of rows and number of columns. At last you should put one semicolon. Here data type is a basic data type. It may be int, float, char, double, whatever it may be. And here array name is a valid C identifier, and rows indicates the number of elements to be stored and processed under subscript 1, and columns indicate the number of elements to be stored and processed under subscript 2, and declaration should be always terminated with a semicolon. See, this number of rows is also called as size 1 or index 1 or subscript 1. This columns, number of columns, is also called as size 2, index 2, or else it is also called as subscript 2. Here we will see one example for this two-dimensional array declaration. So this is a data type, that is int, and this is a array name, and this is a number of rows, and this is a number of columns, and this is a semicolon. So here this array name is a. Here it may be any valid C identifier. Even you can take your name also, there no problem. Already we know the rules to write a valid identifiers or valid variables. So this is array variable. So this array a requires how many memory locations? Here 12 memory locations, because number of rows are 3, number of columns are 4. 3 into 4, 12. Total 12 values or 12 elements we can store in this array a. So it requires 12 memory locations to store these all 12 integer numbers. So in that array, here these are representing row 0, row 1, and this is row 2. Since the number of rows are 3, its subscript or its index start from 0 here also, like one dimensional array, and second row will be row 1 and third row will be row 2. So column number of columns are 4, and column number 1 always starts or indexed or addressed from 0. Column 0 is the first column, column 1 is the second column 2 is the third column 3 is the fourth column. So 3 into 4, totally how many number of elements or values we can store here? That is 12 values. And these 12 values, how to address these 12 values, how to address these location of these 12 values? The first element will be addressed as a of 0 0. Next element will be addressed as a of 0 1, a of 0 2, a of 0 3, and a of 1 0. Okay, so first row and 0th column, and first row first column, and first row second column, first row third column, like this. This element is addressed with a of 1 0, this element is addressed by a of 1 1, this element is addressed by a of 1 2, this element is addressed by a of 1 3. Okay, and similarly here this element is addressed as a of 2 0. In this a of 2 0, any integer value may be present, but its address is a of 2 0. This is a of 2 1, this is a of 2 2, and this is a of 2 3. Now we will see initialization of a two-dimensional array. So initialization is nothing but assigning the values to these two-dimensional array in declaration section only. That is initialization. The first method is there, initialization in declaration section. Here also again we have to strictly follow the syntax for initialization. That is, we should write a data type followed by a space, then we should write array name, and here we will write size 1 and size 2. Size 1 is nothing but number of rows, size 2 is nothing but number of columns. So here only, if you want to assign the values, you can write these all values here separated by comma, and they should be enclosed between braces like this, and again this initialization should end with a semicolon. Okay, and always remember, the total number of these values will be the multiplication of the size 1 and size 2. So data type here is a basic data type, and array name is a valid C identifier. Size 1 is nothing but it is a number of elements to be stored and processed under subscript 1. Size 2 indicates number of elements to be stored and processed under subscript 2, and value 1 to value n must be enclosed within a pair of curly braces, and initialization also must end with a semicolon. Here is one example for initialization of two-dimensional array. That is, a data type is a int here, and space is here, and here array name is here, and it is size 1 and this is size 2. So how many number of maximum values we can store in this two-dimensional array? 2 into 3, that is 6. So maximum we can store 6 values in this two-dimensional array. That is, in these 6 values may be any integer values, but here I have taken 1 2 3 4 5 6 as examples, and these values are enclosed between curly braces, and this initialization statement or declaration statement ends with a semicolon, and uh, the structure of these data or values in memory is like this. So how many rows are there? 2 rows are there. The first row starts with the index 0, second row starts with the index 1. How many columns are there? 3 columns are there. First column starts with the index or address 0, and the second column starts with the second column address or subscript is 1, and the third column address or index is 2. So here this is a 0 0 0 0 value is what here? 1, and 0 1 value is what here? 2, and this 0 2 value is 3, and 1 0 value is 4. 1 value is 5, 1 2 value is 6. So here a of 0 0 is 1, a of 0 1 is 2, a of 0 2 is 3, a of 0 1 1 0 is 4, a of 1 1 is 5, and similarly a of 1 2 is 6. See here, if uh, the number of values in is less than the total size or total memory locations of that two-dimensional array, then what happens? Then all these remaining memory locations will be automatically filled with zeros, or these memory locations will be assigned to zeros. So for example, here int is the data type and array name is a, and here size 1 is 2, size 2 is 3, 3 into 2 6. So as per this initialization or declaration, there should be actually 6 values here, but programmer is storing only how many values? Only 2 values. First integer value is 1, second integer value is 2. And what about this remaining 4 integer values? These 4 remaining integer values will be automatically treated as 0, or they are automatically assigned to 0. So first one will be stored in the address a of 0 0, and this 2 will be stored in address a of 0 1, and these remaining a of 0 2 and a of 1 0, a of 1 1 and a of 1 2 will be assigned to zeros. Okay. We can initialize values to these individual elements of a two-dimensional array from the sets also. It means that here, so instead of directly writing the values, we can write these values in the form of sets also. How it is? Here int and a first size is 2, size 1 is 2, size 2 is 3. It means that there are 2 rows are there and 3 columns are there. So here, since there are 2 rows are there, it means that in this initialization statement, in a set there are 2 subsets will be there, because how many rows are there? 2 rows are there, so 2 subsets will be here. And how many columns are there? 3 columns are there. So in each subscript or in each index there will be 3 values, integer values, since this two-dimensional array is declared as int. Okay, the first value is 1 2 3, and second row values will be 4 5 6. Similarly, one more example is int a of 3 2. It means that there are 3 rows are there and 2 columns are there. So here there should be 3 subsets, and in each subset 2 values must be present here. So this is a 3 subsets, and in each subset 2 values are present. And here a of 3 3, it means that here number of rows is also 3, number of columns is also 3. It means that there should be 3 subsets, and in each subset there should be 3 values. Then initialization in execution section. Initialization can be done in execution section also with the help of a standard input function scanf. And here, since we are dealing with the two-dimensional array, we have to use compulsorily 2 for loops to read the elements of two-dimensional array or to print the elements of two-dimensional array. You may remember in first one-dimensional array we used scanf function in only one for loop, but here, since there are 2 subscripts are there or 2 indices are there, so here we have to, it means that one is row and one is column, so we have to use 2 for loops here. So first for loop will be for I is equal to 0, I is less than number of rows, and I plus plus. Within this for loop, we have to write one more for loop, that is j is equal to 0, j is less than number of column, and j plus plus. This I is indicating the index variable for rows, and j is indicating the index variable for columns. And inside this for loop, here we will read the elements one by one by using a scanf function, that is scanf percentage d ampersand a of I j. Okay, and close this first second for loop here, and close this first for loop here. This is how to read the elements of an two-dimensional array. So now we will see one simple program. This program is simply as written only for reading and printing the elements of matrix or a table. So here hash include stdio.h, it is a preprocessor statement. Then declaration. So in this declaration statement, int a of 10, it means size 1 is also 10, size 2 is also 10. It means 10 rows and 10 columns are there. It means that this total capacity of this two-dimensional array is 100. It can store 100 values or 100 elements. Next, to for indexing the rows, we have to use one index variable, that is I. And for indexing purpose for columns, so we will use one more variable, that is j. In one dimensional array, we used only one variable, index variable, that is I. But here, since we are using two dimensional arrays, one for rows and one for column, we need two variables, one is I and another one is j. And here we have to mention the number of rows and number of columns. In one dimensional array, usually we have taken that variable as n. N indicates how many number of elements you want to store in that array. So here we are going to specify the number of rows, and here we are going to specify the or store the number of columns, and open the main function. Within that main function, enter the order of matrix. Order of matrix is nothing but indirectly it is asking you to enter the number of rows and number of columns by using a scanf function. So percentage d, two percentage d is there. It means that you have to enter two values, one is for row and one is for columns. Both of them are rows and columns are integer, so I used here percentage d and percentage d format specifiers. If it is a float, then I should use here percentage f. Okay, since it is a int, I used percentage d and percentage d. The first percentage d is nothing but row, number of rows, and this ampersand is nothing but address of this variable. Whatever the value you enter, that will be stored in this address, and whatever the value you enter, second value you enter, it will be stored in the this address. Which address? Address of the variable column. Then enter the elements of a matrix. Now this is a very important point. Here we are going to read the values or elements of array. Just now I told you we should use two for loops. First for loop is I is equal to 0, I is less than row, number of rows, I plus plus. Within that we have to use one more for loop. For j is equal to 0, j is less than number of columns, j plus plus, scanf percentage d ampersand a of ij. Printf this matrix is slash n. So now we are going to print that matrix. Just now we have read the elements of matrix. Now we have to print the matrix. For I is equal to 0, I is less than row, I plus plus. Within this for loop, here first we should use one printf function. Remember carefully, very important. Here this is just to, these lines are used just to read the elements or enter the elements of a two-dimensional array, and from here onwards we are going to print the elements or values on a monitor screen or output device. So here we are going to use one for loop. for I is equal to 0, I is less than row, I plus plus. So once you open this first for loop, so you should use one printf function here. That printf function control statement should be only /n/t, because so /n is a new line character and /t is a tab. So if you use this one, your matrix will be clearly, properly will be displayed on a monitor screen, otherwise it will not be displayed properly on monitor screen. This is one trick we need to remember to get the correct output on a monitor screen. After this printf only we have to use second for loop as j is equal to 0, j is less than column, and j plus plus. Within this for loop we should use one printf function, that is /t. It means again one more tab we should use, then %d. So keep it in your mind how to print a matrix. For loop, and within that for loop one printf statement with the /n/t controller string, and after that one more for loop. Within this for loop printf function, and that printf function control string of that printf function should start from again /t only. After that only we will display the element or value of two dimensional array, that is %d. The %d is nothing but value of a of ij. A of ij, this a of ij may be a of 0 0, a of 0 1, a of 0 2, or it may be a of 1 0 or 1 1 1 or 1 2. Okay, after that you close this for loop, and after that close the main function. We will see one more program, that is addition of matrices. See, two matrices are there. One matrix is A, second matrix is B, but we have to add the elements of matrix A and matrix B, and we have to store the sum of corresponding values or elements in third matrix, that is C. Okay, the same type of program you will execute in your lab, that is a matrix multiplication program. But here just before going to that program, first you need to understand this one, that is addition of matrices program. So write a preprocessor statement as hash include stdio.h, then declare the variables one by one here. Int a of 10 10, that is two dimensional array, b of 10 10, that is also two dimensional array, and c is also 10 10. It means to store the sum we have used this c, and we need to use some additional variables like I, j. Okay, I, j already I told you, so these are compulsorily we should use, because here we are going to use a two-dimensional array with two subscripts or two indices. So one is used for number of rows, another one is used for number of columns, and one more variable we need, that is k here for addition purpose. And we need another four variables, m and n. This m and n is nothing but number of rows that we want to enter in matrix A. Okay, so its total capacity is 100 of course, but how many rows you want to use, or how many rows you want to use to store the values, is indicated by m, and this is n. So m and n are nothing but number of rows and number of columns of the matrix A, so we can call it as order of matrix A. And p and q are the number of rows and number of columns of matrix B, so you can call them as order of the matrix B. So open the main function, then you just divide this program stepwise. It means it is just like algorithm, so it is very easy to understand this program. In first step, what you should write here in comment line, I have written step 1 here. Simply you just read the orders of matrix A and matrix B. It means that how many rows you want to enter in matrix A and how many rows you want to use matrix B. Enter the order of matrix A first we will enter the order of matrix A. Order of matrix A means number of rows, number of columns. Number of rows is nothing but m, number of columns is n of matrix A. Now you enter the order of matrix B, that is percentage D. Percentage D, this first percentage D is nothing but number of rows of second matrix, that is B matrix, and the number of columns of matrix B. So second step is check the compatibility of orders of matrices for addition. It means that if number of rows of matrix A, that is nothing but which variable, m. If m is not equal to p, if m is not equal to p means what? It means that the number of rows of matrix A is not equal to number of rows of matrix B. Okay, if number of rows and number of rows of matrix A and number of rows of matrix B are not equal, then matrix addition is not possible. Or else you should check one more condition, that is this is only about the number of rows of matrix A and matrix B. So now we will focus on number of columns. The number of columns of matrix A, if it is not equal to number of columns of matrix B, then it is again it is not possible. What is not possible? Addition of matrices A and B is not possible. So we should first check this condition here. If any one of these two conditions is true, then this statement will be displayed on your screen as output. Addition of A and B is not possible. Else, this else is for this if statement. Else means what? This condition is not true, or this condition is false. Okay, and this is a double pipeline is nothing but logical or operator. Okay, so else means what? That condition is false. If that condition is false, go to step 3. What is that? Read the matrix A. Read the matrix A is nothing but read or enter the values or elements of matrix A. Okay. So for I is equal to 0, you just print one statement here, that is enter the elements of A. I is equal to 0, I is less than m, I plus plus. So I is for indexing of a first subscript or first index, and m is nothing but number of rows. Within this you open one more for loop, that is for j is equal to 0, j is less than n, j plus plus. N is nothing but number of columns of matrix A. So here if these two for loops are written, then you within this second for loop you start reading the elements of two dimensional array one by one, that is percentage D. Okay, and I am percent A of I j. So this A of I j may be of 0 0 0 1 0 2 and 0 3 0 4, whatever, or else it may be A of 1 0 1 1 1 2, whatever it may be. Based on it completely depends on what value you have entered for number of rows variable, that is row of matrix A, that is nothing but what is the value of m and what is the value of n. It depends on A of I j depends on value of m and value of n. Then close the for loop and again close this for loop. Then program continues here. Go to step 4. Now whatever you have entered, no, that is the elements of matrix A. Now you enter the before going to entering the matrix B, we will print this matrix A first. So here printf elements of array A are for I equal to 0, same for loop here. For I is less than m, I plus plus. The only one difference is after opening this for loop, we should write one printf statement here compulsorily. Then only we can display that matrix in a correct structure or format on a monitor screen with some rows and some columns. Otherwise our output will not be displayed properly. In this printf statement, what we should write? 1 slash n and slash t. After that, we open one more for loop, and j is equal to 0, j is less than n, j plus plus. Inside this for loop printf, again this printf starts with the percentage slash t. After that only we start to print the elements one by one. Here percentage d, this percentage d is nothing but a of ij. This a of ij may be of 0 0 0 1 0 2 or anything, 1 1 0 1 1 1 2 1 3, whatever it may be. This it depends on value of m and n. Then close this brace and close this brace. Okay, then step 5, here also read the values of or elements of matrix B. Here enter the elements of B. So how to enter? Again same method. For I is equal to 0, I is less than, this time instead of using m we are using a p, because we are reading the elements of matrix B. In matrix B, number of rows is indicating with the variable p, and number of columns is indicating with the variable q. So here I is less than p instead of I is less than m. Okay, I plus plus. Inside this for loop we will open one more for loop with j is equal to 0, j is less than q. It is not j is less than n. Okay, so q is number of columns of matrix B, and j plus plus. Inside this read the elements of matrix B one by one like this. Percentage d, that is ampersand b of ij. Okay, b of ij may be b of 0 0 0 1 1 0 1 1, whatever it is. Okay, next step is print the elements of matrix B. Elements of B are for I equal to 0, I is less than p, I plus plus. Open this for loop and write one printf statement compulsorily like this, that is slash n slash t. And after that you write one for loop, that is j is equal to 0, j is less than q, j plus plus. And inside that for loop you write once again one more printf with a control string starting from the slash t. Then only you start displaying the elements of matrix B like this, that is b of ij. Close the first for loop and the second for loop. Now the next step is very very important logic of this program, that is step number 7, that is computation of sum, or add the elements of each array. Okay. So for I is equal to 0, I is less than m, I plus plus. Okay, inside that for j is equal to 0, j is less than q we have written, not n here. So here it is q is nothing but, here m is nothing but number of rows of matrix A, and here q is nothing but number of columns of matrix B. Okay, j plus plus. So c of ij is equal to 0. It means that initially we think that c of ij, that is a c matrix, is filled with 0. If I value is 0, j value is 0, I value may be 0 and j value may be 1, and I value may be 1 and j value may be 0. I value may be 1 and j value value also may be 1, whatever it may be. It's we will think that its initial value is 0. Then to start addition we should use one more for loop like this. For k is equal to 0, k is less than n, n is nothing but here number of columns of matrix A. Then k plus plus. C of ij is equal to, c is nothing but some matrix, c of ij is equal to a of ij plus b of ij. Close this third for loop, close this second for loop, and close this first for loop here. So this seventh step is very very important. This is the main logic of this program. Okay, here step number 8. Okay, step 8 is print this matrix C, that is sum. Elements of matrix C are again same steps. For I equal to 0, I is less than m, I plus plus, printf slash n slash t. For j is equal to 0, so here instead of j is less than n, again we should use j is less than q, and j plus plus and printf slash t percentage d c of ij. It means that we are displaying the elements of matrix C, and we are closing the first third for loop, second for loop, and we are closing else here, and at last we are closing the main function here. In next lecture we will go to strings topic.